Levitating Balloons by Emily, Theo, and Zoe. We investigated how adjusting the amount of time we charged an object could alter the electrical force acting between an object and a second object of the similar charge. We hypothesized that the longer an object is charged for, the greater charge will be, thus increasing the electric force acting between the two objects.
The electric force measures the interaction between two charged objects. This interaction can register as either an attraction, negative force value, or a repulsion, positive force value. In this experiment, two balloons were charged for equal amounts of time. Then, using a scale to determine the force acting between the balloons at a constant distance. This was repeated several times with different charge times. The data was then used to determine the charge of the balloons themselves. From this, we could prove the relationship between charging time and charge, thus proving the relationship between charge and force. Several assumptions were made in this experiment. First, that both balloons had the same charge. Second, that our hands would be total neutralizers. And third, that the force created by the balloons was repulsive.
In our models relevant to the system, we take into account our equation for the electric force, which is created when two charged objects act upon one another across a distance. Our electric force is written as the electric force is equivalent to Coulomb's constant times charge 1 times charge 2 divided by our radius squared. We can assume that charge 1 is equal to charge 2 because they are both charged similarly, thus they are the same, and we can adjust our equation accordingly to solve for the charge of both objects. From our force equation, we can manipulate to solve for the charges of both balloons, assuming, again, that they are the same charge. Here we can find that the charge of a balloon is equal to the square root of the electric force times the radius squared divided by the k constant. By determining our value of Q from a measured force at a constant radius, we can prove the relationship of an increasing charge to an increasing force based on the time spent charging the object. We are able to assume that the electric force of two objects is equal to the force of gravity of the first balloon plus the force exerted by the second balloon onto the first. This is because the force recorded on a scale is equal to the gravitational force, and when the scale is zeroed, or tared, we can record the force of charged object 2 onto 1 by taking the additional mass added or subtracted based on if it's an attraction or repulsion, and multiplying it by the acceleration due to gravity, as seen in the equation below. Using the model from the previous slide, we are able to determine our three force values. The times were altered by 5-second intervals based on how long we spent charging each balloon with a piece of wool. We were then able to plug these force values into our manipulated equation to determine the charge of the balloons, again, assuming that both balloons are the same charge.
We investigated the charge of a balloon's effect on one another as the amount of time being charged increased. Each balloon was vigorously rubbed against a fluid surface for 5, 10, or 15 seconds. Carefully, without any other contact with the balloons, we even wore rubber gloves. Being sure not to neutralize the balloon in any way, one balloon was taped to the scale and tarred. This would account for the force of gravity acting upon the balloon. The other balloon was levitated 2 centimeters above. The weight given was then recorded after each trial. Balloons were neutralized with contact of hands before starting another trial. The positive weight proves that the force felt was repulsive. However, there were some faults in our experiment, such as not being fully neutralized balloons, the scales not being accurate as hoped, not being the exact same distance for each trial away from one another, and the charge of the objects being unevenly distributed. However, we combated some of these flaws with multiple trials. However, that does not solve all the error found in our experiment.
We have determined that the electric force experienced between two balloons will in fact be affected as the charge time is increased. This also goes to say that by increasing the time of charging an object, the charge itself will also increase. This proves that as the magnitude of charge increases, so does the magnitude of electric force. Ultimately, it was determined that the longer the time spent charging the two balloons, the larger the magnitude of the electric force between those two balloons.